Hello everyone, hope you guys are all doing well. Today's math video, we're gonna go through questions 32 through 36 in the multiple choice, and then question 16 in the short answer. All right, so question 32 through 36 will all look a little bit familiar. These strategies should start looking familiar to you guys as you go through. So for many of these, you can just go right to the strategy. I'll show you the long way, and then we'll talk about the strategy. So for question 32, the expression x to the fourth minus 16 is equivalent to. So if you see that word equivalent, you know it's the strategy where you can put your original into y1 and then each answer into y2 and find your match. But for this one, it might be quicker just to factor this. So you would want to factor this, and what indicates that you're going to be factoring are your options here. So you can see that you have two parentheses. So we're going to take x to the fourth minus 16. You have to decide, is that a GCF? Do they have something in common? Is it difference of two perfect squares, or is it trinomial? So this is going to be difference of two perfect squares because x to the fourth is a perfect square, 16 is a perfect square, and you have a minus there. So you set up your two sets of parentheses. If you remember that the signs are 1 plus 1 minus, then you can go ahead and cross out B and D as your answer. The way you break up x to the fourth would be x squared times x squared. You always ask yourself what times itself is going to give you x to the fourth. And then what times itself is going to give you 16. A lot of kids mess this one up, and they do so by picking A. They say 8 and 8, but that's 8 plus 8 gives you 16, not 8 times 8. So if you ever are unsure, you can always square root the number. So you can hit second square root in your calculator right there. It's the x squared button. And you can do 16. And it will show you that the square root of 16 is 4. So it's 4 and 4. And so that means C is equivalent. And if you did go ahead and plug x squared, or x to the fourth minus 16 into y1, and then your answer into y2, you would have a match. So that would be the strategy to check your work. Okay, question 33. This is similar to the one where you're going to be matching variables with the numbers that they go with, and then you're also going to be matching all the numbers that represent money in one equation. So you don't even really have to read this whole question. Many of these are similar in the same format as this one. So if I go through and read, the Celluloid Cinema sold 150 tickets to a movie, so that's your total number of tickets. When I realize that's a total, I like to write that one of my equations is going to equal 150. Some of the tickets were child's tickets and the rest were adult's tickets. A child ticket cost $7, so child ticket is $7.75, and then an adult ticket is $10.25, and then the cinema sold $1,470, so that's going to be another total, $1,470. That's the total amount of money that they sold. Which system of equations could be used to determine how many adult tickets A? So that's the variable they're using for adult tickets, which means with this $10.25 amount, I'm going to put an A there because that number is going to go with the variable A. And then they're saying child tickets is going to be represented with a C, so you're going to put a C with the $7.75. And then remember, when you're dealing with money, you want all the monies or all the numbers that deal with money in the same equation. So this $7.75, $10.25, and $1,470 are all going to go in the same equation, which means you can cross out option D because that money total of $1,470, that's represented without the other money numbers, and same with, let's see, there should be another one, B. So those can go away because this $1,470 should be with the other two numbers that represent money. And then you want to see, we'll find the difference between these options A and C. So 1025A is that you have to make sure that the number represents the variable that it should be going with, and in this case it does. And then 775 goes with C. In this case it does. So this appears to be a match. Let's just make sure that this one isn't. This says 775A, and A should be with the 1025 number, so that one's out, which means A is our answer. So for this strategy, it's you're matching money with money, and you're matching your numbers with the variables. Variables. equals. So this is a matching strategy. All right, question 34. Here is another inequality. These ones you do have to solve. You can, in the example from last week, I told you that you guys can go ahead and plug in your options to check which one works, and then you can eliminate some answers. But because we have 2 options of 3, we're gonna have to figure out what the inequality symbol is gonna be, either less than or equal to or greater than. So we do have to solve this one all the way. So the first step here would be to distribute in the 5. So you have 3x plus 2 is less than or equal to 5x minus 20. And then I like to keep my variables on the left-hand side of inequality, so I'm going to subtract the 5x over. And I get negative 2x plus 2 is less than or equal to negative 20. Go ahead and subtract your 2 over. Negative 2x is less than or equal to negative 22. And then you divide by negative 2. And just like in a lot of these other problems, they're testing you really on if you know whether or not what to do when you divide by a negative number across an inequality. So when you go ahead and divide by negative 2, you have to remember that the inequality flips its sign. So you get x is now greater than or equal to, and then a negative divided by a negative leaves you with positive 11. So D is going to be your answer. And you can always plug 11 in for x here, and when you go ahead and do that, you should have the same number on both sides. So it's going to be like a check. So that's the strategy to make sure that you're right. You would check your answer to make sure you get the same number on both sides of the inequality when you plug it in. All right, question number 35 asks for the zeros of the function. So a couple of strategies here are you can go ahead, since f of x equals is part of our problem here, you can go ahead and put that in for y equals and find your zeros in the table. Remember, when you have zeros in a table, that's when y is equal to 0. So you should find the x value that matches up with a 0 in the y value. So I could go ahead and do it that way. I can plug these numbers in for x and see which ones equal 0, or I can factor it. So I'm going to factor it. Since we've done the check a lot of times so far in these videos, I'm going to go ahead and factor this. So let's go back up to our list of factoring. You have to ask yourself, is there GCF? So do they have something in common? Between these 3 terms, they do not have anything in common, so it's not GCF. And then you ask yourself, is it dots or trinomial? Remember, dots is always a binomial. It has 2 terms. So if it doesn't have 2 terms, then you have to move on to trinomial. And since this has 3 terms, it is going to be your trinomial, or we call it the AM, the add multiply method. So above the negative 5, I'm going to put an A, and above the 6, I'm going to put an M. This trinomial happens to be one of the trickier ones to factor because of the numbers you see here. Both 1 and 6 and 2 and 3, depending on the signs, are going to add up to 5. So you have to be very, very careful with your signs here. So I would definitely be checking my work. So we want to see what multiplies to negative 6. So my options are 1 and 6. And remember, since it's multiplying to a negative, one of them has to be an opposite sign. So one of them has to be negative. Or I have something like 2 times 3, and one of them has to be negative. And then you have to ask yourself, okay, which 2 pairs would add to a negative 5? So the only way I can add these numbers to get to 5 would be a negative 1 plus 6 or a 1 minus 6. So 1 and 6 are my options here. I just have to decide which one gets the negative. So if I have negative 1 plus 6, that adds to positive 5. I need this to add to negative 5. So I'm going to do positive 1 and negative 6 as my factors. Now you have to be careful because they ask for the zeros, not the factor. So we have to take it one step further after we factor. So I'm going to break this up, x and x. I have 1 positive, 1 negative because it's multiplying to a negative. And I decided my 1 has to be positive, my 6 has to be negative. And you're setting that equal to 0 since we're finding our zeros. And then go ahead and set up your t-chart and set each factor equal to 0. And then we're going to go ahead and solve those guys. So the signs always just become opposite of what they were. So I'll add the 6 here, x equals 6. So my zeros are negative 1 and positive 6. I would definitely check this one in your calculator to make sure that negative 1 and positive 6 is where your zeros are in the y-axis, or in your y table, just because a lot of students get confused between the factors, which we have right here, and the actual zeros, which takes it one step further, which is the opposite sign. So you never want to get yourself tricked by that. Like in question 32, these are just the factors, they're not the zeros. So I didn't take it that step further. So you just have to always be careful and pay attention to what they're asking. And then in question 36, this one's an exponential, which we didn't really get into the exponential unit. We started it, but we never finished it. So this question might not make sense as far as the equation goes, but you have strategies and you have your calculator, so you should be able to still answer this based on the strategies that you've learned. So the growth of a certain organism can be modeled by this equation, and that's an exponential because my variable is in the exponent. And then it says where C of t is the total number of cells after t hours. Which function is approximately equivalent? So there's that word equivalent again. When you see the word equivalent, you can go ahead, and it's a multiple choice question, you can put the equation that they give you in your answer, in your question, in Y1, and then you can put each one of your answers in Y2, and you would go ahead and match these. Now they said it's approximately equivalent, so it's not going to be a perfect match, but it should be close. So I'm going to go ahead and put in my original equation, which is 10 parentheses 1.029, close the parentheses, and then make sure you hit the caret button. Some of you, if your calculators are not updated, like mine, you have to put in parentheses the 24x so that you hold that together. If your calculator does what mine does, which is actually make room for the exponent there, it like shoots up your numbers to make them small, then you should be okay. So you put that one into Y1, and then we're going to go ahead and put each option in one at a time into Y2. So I am going to start with C. I think, let's see if C and D. The reason I'm going with C and D to start is because this is an exponential growth. And the reason I know that is because that number in parentheses being raised to the exponent, it's greater than 1, which means it's going to be a growth. And so C and D are also growths, so I'm going to start with those just to see if they are a match. So I'm going to do 10 parentheses 1.986 raised to the x, and then go into your table and we're going to check if it's an approximate match. So are these numbers pretty close together? And if you notice, they are. There's some decimal differences, especially as you go down. But for the most part, like for at 0, it's 10 and 10. You always want to check other places. Don't just check your y-intercept because they could be different elsewhere. So you just want to check everything else. But these numbers are pretty close. So that is going to be your answer. So this one was 2 strategies. I used process of elimination to realize that that was a decay and that was a decay because the number was smaller than 1. And then I checked using my calculator. Okay, I've crossed out 37. We're not going to go over that one today. You can do it as a challenge if you'd like to. If you want to do 37, you have to figure out an equation based off this table. So you'd have to find the slope and the y-intercept. And then you'd have to find where the 2 intersect. But it's a bit trickier. So if you're up for the challenge, go for it. All right, and then in the short answer packet, we are going to go through question number 16. We're moving on to solving systems. You actually did a system last Wednesday for your Work Through It Wednesday problem, where you graphed an absolute value and a quadratic. Anytime you graph a system, notice it says solving systems of equations. It ends in an S, meaning it's plural, meaning there's 2 or more equations or functions. 99 times out of 100, there's going to be 2, and you find where those 2 systems intersect. Okay, you're always looking for where they intersect or they overlap. So that's kind of what this box says. It reminds you that you're graphing 2 lines or functions, I should say. Lines is too specific. They could be anything. When you solve a system, you were looking where the 2 functions intersect. There are 3 ways to solve a system of equations or inequalities. So we learned this back in, I don't know, probably November or December. And then you guys also learned this in middle school or maybe in 9th grade if you took fundamentals. Solving a system of inequalities, you can solve it graphically where you graph them. and find where they intersect graphically, which is what we're going to be doing down here because they gave us a graph. You can solve them algebraically using either elimination or substitution. We are not going to get into the algebraic ways today. We're just going to do graphing for right now, but these will be coming soon. This should say elimination and substitution are algebraic. And then don't forget to label your functions. Anytime you graph more than one line on a graph, you must label it to let whoever it is that's looking at it or grading it know which is which. So this one, they give us a word problem. They say graph the inequalities. So this word right here gives a lot away. First thing it tells us is that I'm going to be using inequality symbols like greater than or equal to, less than or equal to. And it also tells me, because it ends in an S, that I need to come up with two equations or inequalities after I read this word problem. Okay, so if you find yourself reading this and only coming up with one, you've done something wrong. You need to come up with two equations after reading this. So the first sentence says, the sum of two numbers, x and y, is more than 8. All right, so sum tells me that I'm going to be adding. It says the sum of these two numbers, x and y. So I'm adding x and y. I'm going to put the plus sign in between those. So it's going to be x plus y is more than. Usually the word is in a word problem is where my equal sign goes, but because it's attached to the word is more than, that's where my inequality goes. So the more than symbol is like this. It doesn't say greater than or equal to or more than or equal to, so you don't put that line underneath, you just leave it plain old more than, like that. The greater than symbol is more than, so that's where it goes, 8. Okay, so that's going to be your equation number 1. The next equation says when you double x and add it to y, the sum is less than 14. So when you double means you're timesing something by 2. When you double x, so 2x, and add it to y, so 2x plus y, the sum is, so they're just referring to this, the answer to this addition problem. So they're saying the sum is less than. So is less than is going to be my less than symbol and 14. So I'm going to go ahead and write that inequality. 2x plus y is less than 14. Okay, so I've come up with my two equations, or my two inequalities, and now they want me to graph them. So before I graph these, I need to solve for y. So I'll start with the first one. X plus y is greater than 8. You got to subtract x over. Y is greater than negative x plus 8. And your options are to either put that into your calculator, into your y equals, and graph it using the table, or you can just graph it using slope and y-intercept. So my y-intercept here is 8, and my slope is negative 1. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. Plot your point on the y-intercept, and my slope is negative 1, so I always like to write it out as two numbers, as a fraction. Negative 1 over 1 means I'm going down 1 to the right. So down and to the right, 1, down to the right, and always double check yourself by making sure it's creating the right direction that you want it to be in. So if it's a negative slope, it should be going in this direction. If it's positive, it should be going in this direction. So you should always be double checking. And then if you remember from last week, when you graph an inequality, you have to ask yourself, is it a dotted or solid line? And then where do I shade, above or below? So there's two extra things that go with inequalities. And there's actually an additional thing because this is a system of inequalities. So for this one, it's y is greater than. So it's gonna be a dotted line. Make sure you have arrows on the end, and greater than means I'm shading above the line. And make sure you go ahead and label that guy. Y is, you can label it with your equation in y equals format or your original, doesn't matter. And then your next equation is 2x plus y is less than 14. You have to go ahead and solve for y for this one as well. So I'm going to subtract 2x over. Y is less than negative 2x plus 14. And now I can go ahead and graph this using slope and y-intercept. My slope is negative 2. You can put it over 1 so that you can see the two numbers. We're going to go down 2, right 1. And my y-intercept is 14. So if this is where 8 was, 9, 10, 11, 12, 13, 14. There's my y-intercept. I'm going to go down 2, right 1, 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 down 2, right 1. Normally in a system, I'd have you circle the point of intersection, but you don't do that for a system of inequalities. And I'll talk about that in a second. So this one's also a dotted line because it's a less than and not less than or equal to. And then when you go ahead and shade this, the shading can look a little complicated or a little confusing when you have two inequalities. So I want you to be careful. I'm going to shade that first one right now, and I'm going to go over it in orange so that you can really see the difference. And notice when I shade, to keep myself organized, I go right from the line in the direction I want to go in. So if this is now the line I'm shading, it's less than, so I'm going to go below the line. I'm going to start at a point on the line and just shade down. Start at a point on the line, shade down. Point on the line, shade down. This way you don't miss anything, or you don't combine the two lines, or you don't mistake one of the lines for the other one. And then you'll never question where your point of intersection or your overlapping section is. So make sure you go ahead and label that line. Y is less than negative 2x plus 14. And then the last step for graphing a system of inequalities is you have to label where your solution is. It is not where the two lines intersect. It's where the shading intersects or overlaps. So where the orange and yellow overlap would be right here. You label that with an S to tell me that this whole section is the solution to my system of inequalities. So the question that they ask you down here, they always like to ask this question. And they like to trick you. So they said, Kai says that the point 6, 2, so over 6 up 2, that's the point of intersection. So Kai says that this is a solution to the system. Determine if he is correct and explain your reasoning. So is this a solution to my system? Well, it's part of the over 6 up 2. I circled the wrong point. Oopsies, right here. So it's touching that section that overlaps, and I told you guys that all this section is part of my solution, but because this line is dotted and this line is dotted, even if just one of them was dotted, you cannot say that that's a point in my system. That's not a solution to my system because it falls on a dotted line. And when they ask you to explain your reasoning, you can say that. So you would say that 6, 2 is not, so Kai is not correct. So you have to first say yes or no. So we're going to say no. Kai is not correct because, and you can just say because the point falls on a dotted line. It actually falls on two dotted lines. So because the point falls on a dotted line. And that would be fine. If they were asking you for a point that lies in the solution, you would have to pick any point inside of this overlapping shading area and not any point on the line. So I would pick maybe the point over 2 up 1, 2, 3, 4, 5, 6, 7. That right here, this is a point in the solution. Any point inside here, that's a point in the solution. So is that. So is that. But if it hits one of those dotted lines, it's no longer a solution. Okay? All right, guys, thank you for watching the video today. I look forward to seeing your work on Sunday night by 11:59 p.m., and I hope you guys have a great week.